Hello everyone. In this unit we are going to look at projectile motion. Now you might be wondering, what exactly is projectile motion? Well, it's the motion of projectiles. What's a projectile? Well, let me define it for you. And a projectile is something which only has gravity acting on it. Right? That means that the air resistance is either not existent, so you're in a vacuum, or it's so small that we can just ignore it. Right, so this wouldn't be while you were throwing something or while you were catching something. This would be while it would be moving on its own. Right, we're going to look at this one-dimensionally, and then we'll eventually branch out into 2 dimensions even. And this is kind of a fun unit. This is one where we're going to be throwing and shooting things around the room and lots of labs and hands-on. So we're going to actually start here with an activity looking at one-dimensional projectile motion. This is an activity which is going to mimic 2 of our previous activities, speeding up and slowing down and moving right and moving left, that we've done in the past, where you're going to predict the graphs for the motion of a one-dimensional projectile, and then you're going to use a motion detector to actually see those graphs, and then you're going to answer some questions about that motion and what it means. So, basic setup is that we have a soccer ball, we have the ground, and we have a motion detector suspended above the ground. Okay? And so you're going to play in this area underneath the motion detector. So there are 3 parts to this activity. The first part's pretty basic. You're going to take the ball and you're going to let it fall on its own to the ground. Now it might bounce, and that's kind of a cool thing to look at on the graphs, but that's not the part we're really looking at. We're just looking at it while it's falling to the ground. So pretty straightforward. The second part will take a little practice. This part you're going to throw the ball up and then catch it at its highest point. So you're not going to let it come back down. Let me show you that again. You're going to throw it and catch it at its highest point. Okay? Now you really have to work at getting this right underneath the motion detector as I'm showing you here. If you throw it and it veers off to the side, the motion detector might lose it. So again, up, catch it at its highest point. And then the third part is combine both and let's see what it looks like. So you'll throw it up and let it come back down. Right? And then catch it or let it hit the ground, either way. So again, up and back down again on its own. Now again, this part has to be right underneath the motion detector, so practice a little bit before you do it. A couple of things here that will help you make this activity work well. First of all, we have a program, of course, to run the motion detector. It's a Data Studio file. If we take a look at it here, you'll notice that it's basically 3 graphs. It's a position versus time graph, a velocity versus time graph, and an acceleration versus time graph in meters, meters per second, and meters per second squared. Okay. Notice here on the velocity time graph, we've already got a linear fit box available for you because you're going to select part of the velocity time graph to see what the acceleration is. Right? As we've done in the past, rather than reading it off the acceleration graph, which can get a little choppy, we'll use the slope of the velocity time graph for this. Notice that you only have 2 seconds of time, because I've locked these axes down. So you only have 2 seconds of time, and I've given you enough space that your graphs should pretty much stay in here. They might go off during the bouncing, but we're not really worrying about that part. Now, remember some things about the motion detector. It thinks of itself as 0 position. This means that your entire activity takes place below 0. So think about what that's going to mean when you're making these graphs. It is set up, however, to read down as negative and up as positive, which is our conventional coordinate system. So anytime the ball is moving down, it'll be moving in a negative direction. If it's moving up, it'll be moving in a positive direction. And also remember that the motion detector has a 15 centimeter dead zone in which it can't see the ball. So if you're starting the ball to drop it or throwing it towards the motion detector, it can't get closer than 15 centimeters. This also helps you not break the very expensive motion detector. So remember all those things, and that will help you interpret what's going on. As I mentioned earlier, you only have 2 seconds to complete a trial. If it doesn't fit, just delete it and redo it. And you might need to practice this a few times without using the computer and then work to get a nice clean trial. You want good clean data. And if you can't get one, you can call me over, but usually if you practice a few times, delete bad trials, you should be able to get ones that you can see a little bit better. Just like we've done in the other two labs though, remember that we only want the part where the ball is moving on its own. So not before you let it go, not after you catch it, okay, or it hits the floor. So you want to get rid of the stuff at the beginning and the end and just look at the parts where the ball is moving on its own as a projectile when only gravity is acting on it. This should be a fun little activity that should only take you about a day to do. So I hope you enjoy it.